Welcome to part 2 of writing algorithms. Now, just making it a heading, this is part 2 of writing algorithms for grade 9 computer studies. So we are still in the basics of writing an algorithm, a very basic one. All the problems you have just worked on, the earlier problems, they were fairly simple. The ones of finding the product and adding numbers, variable numbers together. We will now look at some more complicated problems. To write an algorithm to solve a more complicated problem, we will have to use a bit more brain power. Using a bit more brain power means we have to now start using formulas, etc. A lot of mathematics. We will need to have a bit of knowledge and you may have found out some of the information from somewhere else. The information may be found from a few different sources, maybe your textbook, your mathematics textbook for formulas, the library, Google, or maybe from your teacher. As an example, we are going to work on one problem together. The problem to find the average speed of a car given the journey time and distance. So what do we want? What does the problem ask? We need the speed of a vehicle that traveled a specific time and distance. But we need to find the speed. We have the time and the distance, meaning we need to find this one. This one will be entered by the user, and this one will be entered by the user. Okay, so how do we solve this problem? Firstly, the problem is then, okay, we already know we need to find the speed. This is the one we need to find. This is the ones that we will have. Our analysis, you remember I said we have to analyze. You have to know the formula for speed, meaning speed is distance divided by time. Time needs to be converted if it was entered into minutes. Why? Because we want the speed to be in kilometer per hour. We don't measure kilometer per minute or per second. For example, if we were given 20 minutes, you would divide 20 by 60 and get 0.33. Okay. So if we would get 50 kilometers and we have 20 minutes, it means this 20 is converted to hours. So this is 0.33. So then we use simple substitution, distance divided by time. So this will be 50 divided by 0.33. Okay, so how do we write the algorithm? The algorithm, we obviously need to start, and then we have to initialize our variables. Which variables are we going to use? We know we have to find speed, distance will be entered, and time will be entered. Things to remember that I see is missing when you hand in work. Labeled output. It's extremely important that you show some text followed by your variable. You also forget your indentation. Follow as we go through this problem so that you can see the indentation. Also is missing initialization. So the computer will not know which variables to reserve open memory in its memory. It will not know. You are going to put in a formula inside your algorithm, but the variables never existed. How do we make them? How do we, create them, make them exist? We have to initialize them. Okay, so our first variable would be speed, set to 0 in memory, distance, set to 0 because currently it is 0. There's nothing entered, as well as time. Then we have to enter what is given. What does it say? What is given? The time and the distance. So we prompt the user to enter the time. We prompt the user to enter the distance. Then we have to do a calculation. First, we have to convert the time. So you will see I'm using indentation because that was input. Now I put my process a little indented inward. So the new time now becomes, here we did the calculation. How did we do it? We divided by 60. So the new time, if the time were in minutes, let's change it so that the time, the user has an option. So we can take this away and we can say, if time equals minutes, if the time was entered in minutes, then what must the program do? If it's true, the new time is the previous time divided by 60. And then it stops. It doesn't tell you, it shouldn't do a false execution. It's not necessary. So this is step 1, 2, 3, 4, and 5. And if you already know this, if you start it, you have to end it. And end is not a step. Step 6. Okay, so now we have our time in hours if it was entered in minutes. Now we have to execute a formula to find speed. So we can now say, again, indentation, speed becomes distance, what? Where did we get it? Distance, yes, divided by time, which will be that one. And step 7, so the distance will be divided into the time into the distance, and you will find the speed. And I can output using labeled output. So on the screen or the monitor to the user, it will output the speed is, this will be text. That's why we use the inverted commas, followed by a comma and a variable that's going to hold the value for speed, which is S. And we can stop. The solution would be quite easy if we test it to see, evaluate to see whether it's doing what it's supposed to do. So we can take 50 kilometers and 20 minutes. So we enter the time. I'm just going to test here next to it. Please don't give test data next to your written algorithm. Normally we do test data in a trace table. I'm just going to do a quick test to see whether this algorithm will work. So the time, we said 20 minutes. The distance was 50 kilometers. Is the time in minutes true? So we have to do that step. Now it becomes 20 divided by 60, giving me 0.32. 3. Speed now becomes distance divided by time, meaning I have to write simple substitution. Let me do the substitution so that it's easy for you to see. We can first copy this one here. Speed is distance divided by time. And if we do substitution, distance is 50 divided by the new time, which is 0.33. That answer would be 151.51. And this would be in kilometer per hour. So what will it output? It will output the speed is, you see, when we output in our trace table normally, we don't use those. Only when we write the program, we use the inverted commas to tell the computer, this is not part of a variable, this is text that must go onto the screen. And we output what is currently stored in S, 151.51. So if we do a trace table for this one, I'm going to try and do a rough trace table for you. We would have our columns that will contain the values of our variables. Our variables will be distance, time, and speed. Okay, well, let's make this one decision and speed as well as output. And here we have our steps. Step 1, distance, time, and speed was set to 0. Step 2, enter the time. The time was 20. Step 3, enter the distance, was 50. Step 4, decision. Is the time in minutes? True. So a new calculation needs to be done for time. 20 divided by 60 according to our formula. This gives us a new time of 0.33. Step 6. Now use the formula. Distance divided by time. So this would be, I'm just going to write it in small so that you can know what I'm doing. 50 divided by 0.33 gives me 151.51. And at step 7, it must output without inverted commas. The speed is 151.51. If we were to change this section, I want to show you the impact of the actual impact of labeled output. So we can say in text, a string, not variable, the speed is, and we close it. We put the variable there, comma, followed by more text, kilometer per hour. That will influence the output. It will definitely influence the output because now it will read the speed is, that section, followed by what is stored in that variable, followed by more text, kilometer per hour. The same here. Here it will add kilometer per hour. Double underline. So you can clearly identify which sections was part of our labeled part in the algorithm. That part was in inverted commas and that part was in inverted commas. But when we output, we do not show the inverted commas. It's text to the screen. You will now get a problem to solve. So I'm going to type it for you on the screen and you can copy it down and solve it. Easy as that. Find the area of a rectangle. You now have to decide what variables am I going to use? What is the formula for area? So you will analyze. You will have to analyze. You will have to say, what are my formulas? Which variables would I need? Okay. I'll give the answer in the next lesson.